Welcome friends, welcome you all in my channel Chemistry, the Mystery of Molecules. I am Tanmay. So today we will learn a very important and very famous reaction, ozonolysis. It's very important from class 12 to up to masters, like another other competitive exams. So in this video I shall explain the basic strategy and tricks to find out about the final product, how to get easily, and I will explain the mechanism in details. It generally during my study I observe it is very difficult to get the proper mechanism with justification. So if you really want to learn about this in details, please go through the mechanism, and if you are not interested, please skip and see the informations. Another thing, here I will discuss about alkene and alkyne. Initially I shall explain about alkene and later on I shall about alkyne. So if you don't want to read the mechanism part, skip and go to the alkyne. And this video will be long, so I will split this video into two parts. So I suggest you please watch the two parts, then only you can have an idea about the ozonolysis of both alkene and alkyne. So let's start. From the name you can understand this is a ozonolysis, means a reaction involving ozone. Ozone is a allotrope. Ozone is a allotrope of oxygen. We all know. Okay. So ozone is a allotrope of oxygen, and how ozone looks like? Ozone it's a triatomic molecule. It looks like this, with formal charge positive here, negative here, or it can have a formal charge resonance structure like this. Okay, and this ozonolysis is actually a 3+2 cycloaddition. Okay, cycloaddition. How? So let's start. So you can see this reacts with ozone. How? Ozone is this. Okay, to produce this. So the first I will explain about the tricks, then I will go to the mechanism. Tricks means if you want to perform any ozonolysis, then break the double bond here. One part you add oxygen, means it is that you have to add two oxygen two side. Okay, here. So one oxygen will be added to this one, means this double bond, for example this R3 R4 and here R1, it will be, if it reacts with ozone, one side will add oxygen, another will add oxygen. So what will be the final product? The final product will look like this. If the alkene contains hydrogen, then this part will be aldehyde and this part will be ketone. So in short, this is a strategy to prepare carbonyl compounds from alkene. Okay, keep it in mind. This is a strategy to prepare carbonyl compound for alkene, and if it is alkyne, then the final product will be carboxylic acid. So I will explain it at the end. So this is the trick. If any cyclic alkyne is given, for example like this, then what should we do? Previously you can see one hydrogen, here one hydrogen, so one part will be aldehyde, one will be ketone, it's true. So how? I suggest you ozonolysis. And another thing, always when we are writing about aldehyde, mention about zinc water or Me2S, okay, or Me2S, dimethyl sulfide. So mention this. I will explain every role of every reagent slowly. So if it breaks, so I suggest you to write in this way, keep everything is in intact, means write in this, keep everything. Which bond is breaking? This bond. So we will add oxygen here. I know initially it doesn't look good, but in this drawing we'll try to help you to minimize error. Then how to write? For example, this is 1, 2, 3, 4, 5, 6, 7. So draw 7. 2, 2, 2, 6, 7. Okay. So 1 here. So 2 is here. So 3, 4, 5, 6, 7. So this is. So in this way I suggest you to write. Then there will be a less chance of having mistake. Okay. So this is. And another interesting example is that if means we are generally considering about that double bond alkene, but if we see benzene, this benzene contains 3 double bonds, but the difference of a simple triene and benzene is that it has a aromatic stabilization. Okay, it has aromaticity, and that is the reason, that's why it is stable, so reluctant to react. But under specific condition, or you can say under special condition, that is high temperature, it reacts with ozone. So how to draw this using the trick? So you have to write here of 2 oxygen. You have to write 2 oxygen here. You have to write 2 oxygen here. So that will be the product. So what will be? So as I told you that try to keep everything as it is. Okay. So this 3 double bond is intact, 1, 2 and 3 single bond. So this is 1, 3 single bond. Now you can see there is 1 carbonyl. Similarly here, so this double bond is consumed. Similarly here, similarly here, similarly here, and similarly here. So initially it is. Now if you see this molecule, if you write it properly, this is this. So this name is glyoxal. Glyoxal. What does it mean? 1,2 dicarbonyl compound or 1,2 dialdehyde. Okay. So this is 3 molecule. It produces in presence of zinc water, zinc dust water or Me2S. It will produce. Okay. This. Instead of that, if there are 6 methyls, means hexamethyl benzene, means this hexamethyl, then what will happen? Then here methyl group will add in every case. Okay, this is methyl, this is methyl, this is methyl, this is also. So butane 1,4-dione. Okay, this is simple, but if they provide some tricky thing, for example, instead of benzene, let's take 1,2-dimethyl benzene. Now what could be the product? Simply as this understanding, you will say that under same condition, that 1 mole of this dimethyl glyoxal or butane 1,4-dione and 2 molecules of from these 2 sides, what will produce? Simple glyoxal. But this is not actually the true, because this benzene has a canonical form of So this means that the double bond are scrambled, means spread over. Double bond is not here, is not actually. Benzene is completely delocalized. Bond order is 1.5 between each and each being carbon. Okay, so if you consider this, then what will be the product? If you consider this, then product should be like this plus glyoxal. Okay, and if means here breakage, previously here, right now here and here. So this methyl is this part, this is so sorry, I made mistake. I told the reverse one. If we take this one, then this will be the product, because this here reverse. So this cleavage, so this part 1, 2, 3, this will form, this will here, this will here. So this will produce ultimately 2 moles of this and 1 moles of this. But if this is, if we consider this, then the product is this, because it will break from here, it will break from here. So in this way, this part will produce butanone, 1 molecule. Okay, and this part from this part will produce butanone, and this part will produce 1 molecule of glyoxal, this part will produce 1 molecule of glyoxal. So in this way, this molecule will produce a mixture of 1,2,1,4 and methyl glyoxal. Okay, so this is the tricky thing, you keep it in mind about the fact in case of benzene. In case of naphthalene, if we write this in case of naphthalene, what does it produces? Naphthalene is this, and I have explained in one of my previous video that naphthalene prefers to lose resonance energy of 1 ring. Okay, because this the resonance energy of naphthalene is not the exact addition of 2 rings, it is slightly less. That's why 1 ring will react. And it is observed that in presence of CCl4, 2 molecule of ozone is consumed. Okay, 2 equivalent. And what does it produces? So it will break here according to the tricks. It will break here. So here 1 oxygen, here 1 oxygen, here 1, here 1. So what will be the product? So the product is, this side is benzene. So this side is 1, this side is 1. And what is the other product? Other product is glyoxal. Means this and this. Okay? So I guess you have understood the fact. This same thing happens for other aromatics like phenanthrene also. Phenanthrene means this and this. And this is an aromatic group. So what happens in case of this, under similar condition, it produces, so these are remains intact, this bond is broken, this part oxygen 1, this part 1 oxygen. So this versus this. So remember this ozonolysis properly, because Bart's reduction generally produces diene, generally unconjugated diene, and that is utilized using this. So lots of question may come, Bart's reduction and ozonolysis. Here I am making video about ozonolysis. In next I shall make a video about Bart's reduction. So right now we are going to describe about mechanism. So as I told, if you are not want to read mechanism, try to skip and read the alkyne part. So okay, this. So how this reaction happens? For example, if we take R1 and R2 for simplification, no cis trans, here geometry is not mentioned. So this is, and it reacts with this ozone. As I previously mentioned about the ozone, it is 1,3 dipolar cycloaddition, not nucleophilic electrophilic. Don't think like that. It's a dipolar addition. So this comes here, and it goes. So what is the product? So the product is this is R1 and this is R2. This is called molozide, MOLOZID. This is named as molozide. Okay, and one thing I always suggest, that please try to keep it in mind about the charges, because if you can't count the charge properly, then you will end up, this is a neutral molecule, and addition with a neutral molecule, no elimination, so it will be neutral. So keep this fact in mind. Okay, molozide. Then, and CCl4, ozone, CCl4. And why CCl4 generally prefers? Because ozone prefers to dissolve in non-polar solvent, and it doesn't react with non-polar solvent like carbon tetrachloride. That's why this solvent is preferred. Now you can see these contents, 3 oxygens are attached to each other. We have previously read about hydrogen peroxide, which contains 2 adjacent oxygen, and due to this lone pair repulsion, they are unstable, and that's why they have unique nucleophilic property, which is considered as alpha effect. Even they want to reduce So because this is oxygen is -1, this is -1, so they want to reduce. If they reduce, they produces H2O. Even they can be oxidized. If they oxidized, they produce. If they oxidize, they produce oxygen gas. So in this way, here -2, here 0. So such type of property. So this phenomena is true for ozone because this is -1. So this is reactive. And another thing is lone pair repulsion. That's why these undergo rearrangement. How? This undergo rearrangement in this way. Means this bond comes here, this here, and this here. Okay. Again I am telling this bond will break, it will form a double bond. Similarly, this bond will be eliminated, so it will be a minus. Another thing here, since plus charge generated, this will be stabilized. How? So one part is carbonyl, R2 double bond O. Then another part is, so this is O minus, and this is plus R1. Okay, so this is the most important thing. I suggest you to focus. So what happens this? You can see this thing. I'll write again. This R1 O minus plus. It further reacts with this aldehyde. I am writing it in little different way for your understanding. R1 R2, and it attacks here, and it produces a negative charge O minus, and that negative charge attacks here. Why? Because you can see this is a carbonyl, and we know carbonyl, this is delta plus, this is delta minus. Similarly, it is true for here. Another thing, this oxygen contains a unit of positive charge that makes the carbon center even more electron deficient. So it reacts, and it reacts to produce the trioxolone derivative. What does it look like? R, this oxygen, this oxygen. This R2 here, R1 here. Means it will attack here, so this 2 oxygen is this 2, and this 1 oxygen attacks here, this is this oxygen. Another thing, still it contains peroxy. Still it contains peroxy linkage. So what will happen? So this will break into the corresponding product. Means, what do I mean? It will be broken in this way to produce R1, this is R1 CHO, and R2 CHO plus hydrogen peroxide. And if we use zinc water, this hydrogen peroxide will quench to this hydrogen peroxide, and zinc oxide will reduce. This zinc plus H2O2 will reduce to prepare zinc oxide plus water. Similar thing happens in case of dimethyl sulfide also. So it reacts with hydrogen peroxide to produce dimethyl sulfoxide, that is DMSO plus water. Okay, so actually what is happening? This is broken in to produce the aldehyde. So this discussion I shall stop here. In second part I shall explain about how this is happening, role of every reagent, and finally alkyne ozonolysis. So I suggest you to see the second video also.